Okay, so now I'm going to do some examples of using the gradient formula to find out the gradient of a straight line. So to start off with, we have line A, B. So the notation, or the way you write this, is you have M, which means gradient of, and then subscript A, B. So we know from our last lecture that the equation for gradient is m equals y2 minus y1 over x2 minus x1. So for this point, we'll label the coordinates. So this is x1, and that's y1, and that's x2 and y2. So this just makes it easier for me to keep everything, track of everything. So y2 is 6 and y1 is minus 5, so it's minus 5. So that in brackets to make it a bit clearer. And then x2 is 3 and x1 is minus 4, so minus 4. And minus is a plus, so 6 plus 5 is 11, and 3 plus 4 is 7. So that gives us our gradient of 11 over 7 is our gradient of MA. So we'll now look at the next point, CD. So MCD. Now, just to clarify, this is something I used to struggle to get my head around. So how do you know which point is x1 and which point is x2? Well, because we're looking at how the gradient changes as you go along the x direction, the x1 is always going to be the coordinate with the smallest x value. So in this example, the x1 is going to be at C1, y1, and x2 is going to be at D, x2, y2. So let's work this question out. So y2 is minus 6 minus 2 all over 6 minus 1. That equals minus 8 over 5. You can see here that there is a minus sign, and this means that this slope has a negative gradient. I'm going to go and show you how to make sure you always can tell if a gradient is going to be positive or negative in the next lecture. Thank you.